Hello, I'm Joseph. I wanted to talk about Swift outside the context of iOS and macOS. So the first thing I'm going to show is a little bit of a project I've been working on for the last several weeks, and it's simply because um, I had to jump into concepts of Swift that I've never had to jump into before, specifically with C-interop, and then working with kind of high concurrency and parallelism, which is something that you really don't have to do for like a little simple macOS or iOS application. So this is a little SDL2 project that runs on Windows, Linux, and Mac. It uses Nuclear GUI framework with the SDL, I guess, add-on or plugin, and yeah, so I can interact with all this stuff here while this is all rendering 100,000 particles. And this is like an M1 Mac Mini. This is not a very good iGPU built into this machine. I'm also recording the screen, and so I have my FPS from my render loop separate from my logic loop, and this is running at 300% CPU. Um, and you can see that I'm only using like 30% of the GPU. I could technically render a crap ton more particles. My general issue is that I can't because of the amount of memory I'm working with. If I go to my memory tab, you can see I have 200. Sometimes it goes higher than that, but it's like 250, sometimes 300, depending on what I'm trying to do. Um, yeah, there's a lot of memory thrashing. That's the simple way to put it. There's a lot of data working on the RAM that's being moved around and stuff like that. So that's my main limitation. It's not an actual render issue. Um, so yeah, let me just go ahead and jump into the first thing we want to touch on, which is the developer experience. Okay, Visual Studio Code, basically all you're going to be able to use. The Swift LSP is not specific to Visual Studio Code. It works on Vim, works on NeoVim, but what I'm about to say is going to apply to both of those as well. The LSP is bugged, it crashes, and requires you to restart Visual Studio Code quite frequently. I'm sure there's a lot of work being put into this. I'm sure there's a lot of work being put into the Visual Studio Code plugin to integrate the LSP as well. If you don't know what that LSP is, it's a language server protocol Visual Studio Code kind of made up or made, and then a lot of other editors like Vim, like NeoVim, are using that LSP as well. So you can make one LSP on one language server for Swift, and then these other editors can consume that LSP or language server protocol. It crashes a lot. It's slow in some instances. Sometimes it's thinking and it doesn't ever finish. So like if I try to go to my update render buffer, you can see the little blue bar kind of like dancing across. It's never going to finish. I have to restart Visual Studio Code to get this to work. I don't know why that's the is doing this, but yeah, I can't do anything right. I can't jump to anything. It's not crash specifically. Sometimes when it crashes, you can just restart the LSP. I don't know how to restart the LSP in Visual Studio Code offhand. If I do, let's try to do a reload here. So how do you reload Visual Studio Code? Restart to update. I'll leave it. Doesn't matter. But it proves my point. It just like and then I'm not getting much help now. Like the LSP's cooked. Um, and some other systems, the LSP just runs at like 100% CPU of one core, just trying to do nothing. It's not doing anything in the background. I showed that as like a little short of mine. And I'm not trying to crap on this. It works great when it works. Um, it just it's not very consistent compared to Xcode. As much as I hate Xcode, um, but at least you can use this on Linux. You can use this on Windows. You can use this on Mac. You're not stuck with Xcode macOS only. So this is the only kind of real option you have for working on Swift. Now, with that, if you're going to be running it on these other systems, you're going to have to make your own Swift packages or take additional existing Swift packages and make them work. The more specific case will be Windows because that's the harder one. So SDL2 was a package I found by somebody, I believe, yeah, this is the guy that authored it. I've updated this to work better for compiling on Windows and Linux. Um, and then I use it as a blueprint to make my other packages here. So this was a start because this was the only package I found that worked in Windows, Linux, and Mac. They have a PowerShell command here that I've modified by it's VC package for Windows, which is like a package manager for C, C++. It's you think about like Conan or some other package managers on Windows. It's the general idea, but just for C code specifically. And I really, really like that, but it's not really built in. Swift Package Manager or Swift PM, the Swift package here, does have APT built into it. All that does is look for this package on the machine for like a Debian Ubuntu, and if it doesn't have it, says, "Hey, warning, you don't have this," and then it will fail to compile. It doesn't actually install it for you, but at least it'll tell you, "Hey, you need to apt get install this package here to be able to compile this." And then there's an open ticket for VC package, because obviously it would be nice to have on Windows as well, saying, "Hey, you don't have this on Windows. You should VC package install SDL2 TTF because it's the package name on VC package." Interrupting with C is fairly simple though. I'm going to give you an example here of TrueType font. They have a module map, which you include, okay, we're going to work on C. We're going to export all the functions and everything else in there. We're going to put this under umbrella, kind of like isolate it. And we're going to link the library. This would be like a .dll. This would be a .so, .a file, .dylib, that type of stuff. Pretty basic. This is what it would be called. So it'd be like SDL2 underscore T TTF.dll on Windows. And then all that does is include this. But that's all it is. This shim here is just on Windows. How you find that header is a little bit different than it is on Linux. And then on Apple, because I'm following the kind of blueprint the other project had, I pre-compile the Mac version as a framework, which is kind of like you kind of think of it like a static library, or it's not even a DLL. It's just like a static library that includes everything it needs to. And then you can easily get this on your iOS. You can get this on your tvOS, visionOS, watchOS, that type of stuff. But not all of these SDL sublibraries support all those platforms. So pretty basic there. And then for the package Swift stuff, there's the binary target for the SC framework, and then the system library that you would use for Windows, Linux. All really, really straightforward stuff. But there are some gotchas to all this. You just can't include a C header and everything magically gets translated over. One problem I had specifically with Chipmunk is that it does a lot of forward declaration in C. If you don't know what that is, it's a technique you would use to self-reference things like a node system where you have like a node self-reference itself in a C structure. You need to forward declare your C struct. If it sees that in Swift, sees that in the header, it just ignores it, and every function that references that structure becomes an opaque pointer. So you have no idea on the data type you're passing into these functions, and it's very easy to crash your application because of that. And so you can do some work, and there are some things I did need to do for Chipmunk specifically, which is a 2D physics engine that you can incorporate. I really, really like it. It's a lot easier to understand than the other like box 2D stuff. But I did have to put quite a bit of work to get some of these structures to come over because they were all forward declared. Then another project here, Nuclear. Nuclear is that GUI framework I showed here. This is a single header file, so I don't need to do any special um, compiling to make a macOS precompiled version. It simply compiles it with Clang, the built-in compiler here, and it's the SDL plugin or add-on I've included as well. Module map, pretty basic on what this does here. I did have to include this bit here because of how the module map works. I'm not sure why I'm getting curly based on that. And then another issue I ran into was anything that is in a C define, like if I go back here, any of this stuff gets completely ignored by the Swift bridging automatic bridger. And so if you have any defines that are aliases to our constants that you would use to define those, none of those gets pulled into your project, and you have to redefine them in your Swift code. And then another issue I ran into specifically with Nuclear was that if you have a function name, same function name as the C structure, which some libraries would do as like a constructor type of thing, um, it cannot map that properly and completely ignores that function, and you need to make a proxy or alias of that. So instead of calling this nk font config as the function name, I had to give nk font config create because there's no way to call this in Swift without it trying to like have a panic attack of like, hey, I don't know what this is. This is not a C struct, and the name of the C struct is there. It's just the function is not. It's just ignored. So you have to make that mapping. The last bit I'm going to go into is the actual code to make all this parallelism work, and I'm going to try to like give the dumbest explanation of to give you the best starting experience into asynchronous work and specifically parallel work in Swift. It's okay to copy data. It's okay to copy data back, copy data in, copy data back. It's okay to have that. We're getting to the point where these machines are the RAM speeds are so fast that this 100,000 particles, the limitation why I can't render more effectively is actually um, iterating over this 100,000 times per frame. If I push this up to like a million, which I can do, I'll get like, I don't know, 20 frames a second. And it's not a rendering issue. Like if I look at my process manager here, I'm only using 34% GPU, but I can't. My logic loop is struggling. It's struggling for a reason that I'll get into, but it's using 300% CPU, so it's working in parallel, and it's specifically the logic loop that's working in parallel. Now, um, prior to Swift 5.5, you had dispatch group queue, which came from Objective C, and it's fine. You can use traditional locking stuff. It's very much like you would use in C, C++. It's still detached from the understandings that you would take in, but it's better than nothing. Swift 5.5 introduced tasks, task detach, actors, and stuff like that. A lot of stuff that you would use to get this concurrency stuff to work. Um, this starts a task or a thread, but moves it off the main thread. And this is important for SDL specifically because the render loop has to be on the main thread. I cannot move it into its own little task. Even if it's asynchronous, it doesn't matter. It needs to be on that same thing. And then anything you access in the task cannot be accessed from other tasks very easily. This is why I'm talking about the whole it's okay to copy data. And so, a little trick I have here, why this is so performant, is that there are there's the duplicate of particles. So this is actually how right now every loop dealing with like 300,000 particles, and I'll go into that now. The reason why is that every time I wanted to access any bit of data out in another task in the main loop in a task detached, I had to use at main actor. Every time you use at main actor, it puts it to the main thread, and every time it needs to go to the main thread, it's game over. There's no point to having that parallel work there. So that's what I'm saying. It's okay to have that copy of that data, but you have to be careful on how you structure your classes or your structs. I believe they're called structs. Let's double check it. Yeah, how you structure your structure. You only want the data that's needed in that task. You don't want to have like a really fat structure or class that has data from all this other stuff where you're trying to do object-oriented programming and you have like managers being passed into here to manage the like it becomes too much and you'll be banging your head against this compiler in strict mode that Swift 6.0 added. So if I go back to the manager here, um, right here, this this update particles is where all the bread and butter is at, the meat and potatoes. It takes a task group and then like this is cool because this is what I'm used to in like PHP code, where you are specific to saying, hey, we're going to include this information here. Like in PHP, when you have a closure, you have to specify the information. I think C++ does this too. You have to specify what is being copied. You can't just grab everything outside of the function. And then I make a group. I make a group of tasks based off the number of processors minus one because I don't want to touch the render loop specifically. And so it makes these, sets or chunks of an array. So it takes that 100,000, makes a copy of them in chunks, and then comes back and joins them all together. So it's that another 100,000 copy. Um, and then one uh, optimization I had to do was removing particles. When you are dealing with an array that is 100,000 long and you delete a single element in the middle or something like that, it needs to realign all of those. And I'm using a contiguous array here, meaning all the memory is aligned for that. It's a very, very expensive call to do to delete it. So instead, I actually mark it as like quote unquote delete it, but it stays in that array to be reused later on. That was a really, really important part because that was where all the performance was being lost here, was just trying to delete it. So that's how I'm able to get these lovely 100,000s to continue to produce more particles as the other ones die without it dropping the logic FPS dramatically. And then the last thing I do is I do a render buffer. Now, this you think about like swap buffer, for a double buffer, triple buffer. You're copying, you're having copies of data, and so here I have two copies of these particles. One is that it's an active data set that the logic loop will use. It then creates a copy once it's finished doing all the manipulation back into the render loops version of that to be able to use. This way, I don't have to worry about if there's a bunch of stuff happening on the logic, I'll say like logic thread that is still trying to access it, and it cannot do that because the render loop is trying to render the vertices needed for it. So another reason why you see these, I guess, squares rendering so quickly, specifically in SDL, because it doesn't have a very good renderer, is that it's actually using the SDL geometry function or feature. I was adding SDL 2 point whatever, which is hardware rendering. And I'm assuming this is either Metal or OpenGL. I don't know what the backend for this is offhand, but yeah, it's rendering a bunch of particles very, very quickly. Um, and that's basically it. You can see that there's not really anything specific about main actors or any of this other stuff. I was able to keep all this outside of that, which was really, really cool. I'm very happy about that. But it took a long path to get there, very frustrating path, trying to work with the strict mode compiler for concurrency, telling me about race conditions. And I will say the strict mode is not foolproof. That when I got this to work on my Linux machine, actually no, I got this to work on this Mac machine here. I went to compile it for my Linux machine, and then it was telling me other race conditions that the for whatever reason this version wasn't telling me about. I don't know why. So whatever it's a start. I think is the best way to say it for the concurrency strict mode. I think it's necessary for Swift. I really like Swift as a language. I would say there's some rough spots in the language department because it's interopting with Objective C and now C and now also C++ with Swift 6. Um, there's some hard things to deal with, but I think if you want something where you don't have to jump down to C or C++ or Zig or Rust or Nim, and you don't want to go higher up like Go, C sharp, Java, Kotlin, that type of stuff. I think Swift just hits this like really nice medium, but unfortunately, unless a bunch of packages just really easily get Windows support, um, it's going to be really difficult to work on Swift on these other platforms. And I think the last bit here to really touch on is the editor experience, the developer experience. Oh man, um, I don't know what to say. I want an IDE. I want an IDE that's not Xcode, or if Xcode was to ever come to Windows and Linux, sure. But I think if the Swift Foundation or maybe Apple wants to really get this to work beyond just you know iOS and macOS, you're going to need a better developer experience.